If you manage a commercial or industrial building, you could be paying for more power than you're actually using, and something called power factor is to blame. Not only does this make your electricity bill more expensive, power factor also increases our collective carbon footprint. By the end of this video, you'll understand what power factor is, the formula to calculate it, and how to reduce the wasted energy that's a part of power factor. First of all, power factor is the ratio of active to reactive power. Reactive power is power that's generated but lost along power lines in the form of heat in an AC circuit. Active power is power that is actually consumed by an electrical load, such as a toaster, for example. Our ideal power factor would be 1, also called unity, which means 100% active power. When something is 100% active power, it means that all the power that's being generated is also being used for electrical loads and no power is being wasted. If a power factor is 95%, for example, this means that 5% of the electricity being transmitted is lost as reactive power before it makes it to the electrical load. Let's take a look at how the formula for power factor reflects this. As you can see, power factor is a ratio equal to active power over apparent power. Active power is the power that can actually be used by the consumer, and apparent power is the power that's generated for the purpose of consumption, but it includes reactive power. Because apparent power includes reactive power, we know that some of it will be lost in the form of heat along power lines. Take a look at this beer glass analogy for power factor. You can think of reactive power as the foam in a beer glass. Ideally, we would have a beer glass full of beer that can actually be consumed. And since foam doesn't really quench thirst, we want as little of it as possible. It's the same thing with reactive power. We want as little of that as possible too. If you take nothing else from this video though, remember this. Power companies have to take power factor into consideration so that they can accurately generate and transmit enough AC power to make up for the inevitable power losses due to reactive power. Even though homeowners don't pay for reactive power, like commercial and industrial building managers do, we all still pay for lost energy in other ways. The need to consider power factor might make our electrical bills more expensive, but it also has broader implications for the environment. When we generate more power than we consume, we have an efficiency problem, which unnecessarily increases our carbon footprint. So we need to be thinking about ways to bring the power factor closer to 100% active power so we're not wasting precious energy and resources. So, is there a way to do this? I might have said power factor is inevitable before, but really it's just inevitable in alternating current or AC electrical systems. AC electricity has a frequency, and this frequency is what creates reactive power. But if we were to transmit and distribute DC power, which has no frequency, power companies would no longer need to consider power factor when generating electricity. That's not to say that there would be absolutely no power losses along power lines. Distributing DC power would just eliminate the losses due to reactive power. But the transmission of DC power also has less capacitance losses than the transmission of AC power, so power losses along lines would still be much lower. Maybe you're wondering if there's anything you can do in the meantime while you wait for DC power to be distributed directly to buildings. Well, there actually is, yeah. You could distribute DC power locally throughout your building by implementing a DC power distribution system. It's easier and more cost-effective than you might think. Just check out the Argentum website to learn more. And if you're interested in learning about what technologies need to be developed in order to proliferate the market with more DC power distribution systems and transmission systems, check out our blog post on this exact topic. See you in the next one, and hit that like and subscribe button for more content like this.